Hello everyone. In this video, I'm going to solve a second example on optimization problems with quadratic functions. Alright, a Norman window is constructed by adjoining a semicircle to the top of an ordinary rectangular window. So we have a rectangular window, and on the top of it, we have another semicircle. The perimeter of the entire window is 16 feet. Now, before reading the questions, let us do a little sketch in order to understand what's going on. So this is a rectangular window with a semicircle on top of it. Let us assume that the width of the rectangle is x and its length is y. For the semicircle, its diameter is x. Thus, its radius is half x. After we have labeled the dimensions of the rectangle and the circle, now we can proceed with the question. We are given that the perimeter of the window is 16 feet. Let us express the perimeter of the window in terms of x and y. So the perimeter of the rectangle is the following. The sum of this side, that is y, plus this side, that is x, plus this side, that is another y, as well as the perimeter of the semicircle, which is half into 2 pi r. Of course, we're not going to count this side, but we have already found r in terms of x, which means we can replace r by half x. So the perimeter becomes p equals 2y plus x plus half times pi times x. And we are given that it's equal to 16. So we've got a relation between x and y, and consequently we can find y in terms of x. So 2y is equal 16 minus x minus half pi x. Let's divide everything by 2. And we got our y. We can factor negative half x in these two terms, so we end up with the following expression of y. Now it is time to read and answer the first question. We are asked to find the dimensions which are going to produce a window of maximum area. When we say dimensions, this means we have to find the length and the width of the rectangle as well as the radius of the semicircle. But we have r in terms of x. And we just found y in terms of x as well. Thus, if we know the value of x, we can calculate all the dimensions. So our goal for now is to find the value of x, which maximizes the area of this window. Since we are talking about area, this means we have to find an expression of this area. Alright, the area is equal to the area of the rectangle plus that of the semicircle. The area of the rectangle is width times length, so that is x times y, and the area of the semicircle is half pi r squared. Now we plug in these formulas into the expression of the area in order to end up with x only, and we end up with this. Let us now simplify this expression. We get this. Let us now factor negative half x squared from these two terms. And this is what we get for the area of the window. As you notice, we've got a quadratic function. Moreover, a is negative, which means that the vertex of this parabola is a maximum, and this exactly matches with our exercise. So in order to find the value of x which maximizes the area, all we have to do is to find the x of the vertex, which is equal to negative b over 2a. And we get the following. Minus b is 8, and 2a is 2 times negative half into 1 plus pi over 4. We cancel the 2's and the minuses and find a common denominator here. This is 8 over 1, so it becomes 8 over 1 multiplied by the reciprocal of the bottom fraction, and we've got our x. So we can find the length and the width of the rectangle and the radius of the semicircle. Now y is equal to this expression, and this is the length of the rectangle. We replace x by the value that we just found, and this is what we get. Let us simplify the 32 with 4, which is 2 times 2. We are left with 8 here. We get this, and now we find a common denominator, and that's the value of y. What about the radius? Well, it is equal to half x, and this is 16 over 4 plus pi as well. And this is part A. We now move on to part B, and we have to find the maximum area of the window. So all we have to do here is to plug in the value of x we found into the expression of the area, and we get the answer. So we get this expression, so it's negative half into 4 plus pi over 4 into 32 squared, that is 1024 over 4 plus pi all squared, plus 8 times 32, that is 256 over 4 plus pi. We can cancel 4 plus pi with one of these. We also have 2 plus 4 is 8. So we simplify, we divide 1024 by 8, and we get 128. So we are left with negative 128 over 4 plus pi, plus 256 over 4 plus pi as well. And the final answer for the maximum area is 128 over 4 plus pi. I hope you enjoyed the video. Thanks for watching and see you soon.